You've looked at the moon your whole life. But what if I told you it's hiding secrets that defy logic? From sounds we can't explain to shadows that shouldn't exist. This isn't just a rock in the sky. This is a puzzle. And once you hear these facts, you'll never see the moon the same way again. Imagine a world where Earth spins wildly, oceans flood continents, and seasons vanish into endless chaos. This nightmare was our reality until the moon stepped in as silent guardian. 7 times, invisibly, it saved us from total extinction, and you've never noticed. Stabilizing Earth's tilt. Earth rotates on an axis tilted at precisely 23.5 degrees. This perfect angle creates our familiar cycle of seasons. Spring blooms, summer warmth, autumn harvest, winter chill. Without it, life as we know it wouldn't exist. But here's the hidden truth. That tilt isn't self-sustaining. The gravitational pull of the sun and other planets constantly tugs at Earth, trying to throw it off balance. Over thousands or millions of years, our axis would wobble chaotically, swinging anywhere from 0 to 85 degrees or more. Imagine the catastrophe. One side of the planet scorched under perpetual sunlight for months, temperatures soaring past 100 degrees Celsius, turning forests to ash and rivers to steam. The opposite hemisphere plunged into endless night, gripped by sub-zero cold that flash freezes oceans and buries continents under mile-thick ice. No gradual thaws to melt snow and feed rivers. No reliable monsoons to water crops. Global agriculture collapses overnight. Starvation sweeps across the globe, toppling empires before they can even form. Human civilization? Impossible in such unpredictability. Look to Mars for proof. That red world once held vast oceans and flowing rivers, teeming with potential for life. But its puny moons, Phobos and Deimos, couldn't stabilize its tilt. Wild axial swings triggered runaway ice ages and scorching hot spells, stripping away its atmosphere and leaving a barren wasteland. Earth could have shared that fate. Enter the moon. Towering 384,000 kilometers away, its massive gravitational influence acts like a cosmic gyroscope. It locks our tilt in place, countering the solar system's chaotic forces with unyielding precision. Day after day, for 4.5 billion years, this silent partner has kept our world steady. This stability didn't just enable seasons, it birthed agriculture. Ancient farmers along the Nile could predict floods and plantings. Rome's legions marched through temperate climates. Every city skyline, every loaf of bread, every technological leap traces its roots to this lunar anchor holding chaos at bay. Without the moon, no pyramids rise from predictable Nile floods. No Renaissance flourishes in stable Mediterranean summers. No Apollo missions launch from a planet whose spin doesn't betray it. We'd be nomads, forever chasing habitable zones across a flipping world. Tonight, step outside, gaze at that pale crescent or full glowing orb. It's no mere nightlight or romantic backdrop. That silver guardian is the sole reason your coffee grows in predictable tropic. Your home stands in temperate zones. Your very existence unfolds in rhythmic safety. The moon's first invisible save, freezing Earth's tilt in time, gifting our planet the breathable, livable rhythm that allowed life to thrive. Civilization owes it everything, but this is merely the opening act of lunar salvation. The moon has more shields up its sleeve, regulating the climate. Why did Mars fail to nurture life? It had water, atmosphere, even warm rivers flowing across its surface billions of years ago. But something went catastrophically wrong. The answer lies in stability, or lack of it. Mars spins on a tiny axis tilt, but without a large moon's gravitational embrace, that tilt wobbles erratically over millions of years. Climates flip violently, scorching hot poles one era, frozen equators the next. Earth dodged this bullet. Our moon enforces rigid seasonal consistency, distributing sunlight evenly across hemispheres year after year. Spring always follows winter. Monsoons arrive predictably. Ecosystems thrive in reliable patterns. Without lunar regulation, Earth's climate would mirror Mars's chaos. Polar ice caps would melt and refreeze unpredictably, flooding then starving coastal civilizations. Tropical zones would swing to Arctic cold, wiping out rainforests and coral reefs in cyclic destruction. Imagine ancient Egypt's Nile drying to dust during sudden freezes, or the Amazon turning to tundra. No steady growing seasons mean no breadbasket regions. Famine becomes the norm, not the exception. Human progress stalls in survival mode. The moon's tidal lock on our orbit creates this climatic clockwork. It moderates temperature extremes, prevents runaway cooling or heating, and maintains the Goldilocks zone where life flourishes. Every breath of stable air, every bountiful harvest flows from this unseen regulator. Modern science confirms it. Computer models show moonless Earths developing extreme weather bands, uninhabitable latitudes expanding, biodiversity collapsing under climatic whiplash. We'd be a pale blue dot trending red. Yet here we stand, in a world of balanced beauty, temperate zones perfect for cities, fertile valleys yielding abundance. The moon didn't just stabilize tilt, it sculpted our very weather into life's cradle. Second lunar miracle, climate control on a planetary scale, turning potential Martian hellscape into Eden. But the moon's interventions run deeper still. Slowing Earth's rotation. 4 billion years ago, Earth whipped around its axis every 6 hours. Dawn chased dusk in frantic rhythm. Winds howled at 300 kilometers per hour, whipping oceans into towering walls that smashed continents relentlessly. Life couldn't breathe in that blur. Photosynthesis starved under fleeting sunlight. Animals couldn't evolve complex behaviors. Every creature scrambled in perpetual hurricane-force gales, drowned by tides rising every 3 hours. Then the moon intervened. Born from a cosmic collision, its gravitational drag acted like cosmic brakes on Earth's spin. Inch by inch, over eons, it stretched our days from 6 frantic hours to the perfect 24-hour cycle we know. This wasn't random fortune. The moon's tidal friction transfers Earth's rotational energy to its own orbit, gradually slowing us while stabilizing everything. Without it, we'd still be trapped in that chaotic sprint. Too fast for ecosystems, too violent for evolution. Consider the gifts of this lunar slowdown. 24 hours sync perfectly with circadian rhythms. Sleep, wake, hunt, grow. Plants complete full light cycles for optimal photosynthesis. Human societies build around dawn to dusk work, night rest, seasonal planning. No moon means no stable day-night balance. Coriolis forces warp weather into supersonic storms. Super short days prevent complex food chains, intelligent brains, technological progress. We'd be simple burrowers, not star-reaching civilizations. Modern physics proves it. Venus spins backwards at glacial 243-day pace from similar tidal chaos. Mercury flips wildly without stabilization. Only the moon tamed Earth's frenzy into life's perfect tempo. Every sunrise you witness, every full night's sleep, every ambitious project spanning days, traces to this invisible lunar hand that braked our world from madness to mastery. Third save, extending Earth's spin into the Goldilocks rhythm where consciousness could awaken. The moon didn't just slow time, it created it. Enabling life on land. Billions of years ago, life huddled in Earth's oceans, simple microbes thriving in endless blue. But to conquer continents, to birth forests, dinosaurs, humans, something extraordinary was needed. That spark came from the moon. Its relentless gravitational pull churned shallow coastal waters into tidal pools, rhythmic basins that filled with ocean riches at high tide, then drained under sunlight at low. In those lunar cradles, the impossible happened. Marine creatures faced air, desiccation, gravity. Harsh tests no deep-sea dweller survived. But tidal survivors adapted. Lungs from swim bladders, limbs from fins, waterproof skin from scales. Amphibians crawled forth. Without moon-driven tides, no such evolutionary laboratory. Oceans stay flat. Lifeless shallows never form. Life remains aquatic forever. Whales the pinnacle of intelligence. No land-based brains to dream of fire or flight. Evidence abounds. Fossil records show first land vertebrates emerging precisely when tides peaked strongest, 400 million years ago. Modern horseshoe crabs still migrate by lunar cycles, proving tides as life's boot camp. The moon didn't just stir waters, it sculpted evolution's path. Every tree shading your path, every bird in flight, every human footprint in sand, traces to those ancient moon-pulled waves that coaxed life ashore. Coral reefs explode eggs on full moons. Sea turtles nest by tidal precision. Our calendars echo lunar months. Land life isn't separate from the moon. It's its direct descendant. Fourth miracle, tidal pools as evolutionary incubators, launching biology from sea to summit. The moon waved life onto land, and we've been climbing ever since. Shielding Earth from asteroids. The moon's surface is a battlefield. Thousands of craters pockmarking its face, each a testament to cosmic violence. Those impacts weren't meant for the moon alone. Many were aimed at Earth, deflected or absorbed by our lunar shield. Gravitational physics explains it. The moon sweeps a vast area in Earth's orbit, gravitationally tugging asteroids and comets toward itself. Massive strikes that could sterilize continents slam into lunar rock instead, vaporizing harmlessly in vacuum. Consider the South Pole Aitken Basin, the solar system's largest crater, over 2,500 kilometers wide. That Mars-sized impactor would have boiled Earth's oceans, ended all life in a single cataclysm if it struck home. The moon took the blow. Countless smaller threats follow suit. Meteor showers we admire as shooting stars. Lunar gravity funnels them away from Earth. Without this shield, our atmosphere would scar like the moon's. Skies ablaze nightly with civilization-ending fireball. Historical close calls confirm it. The 1908 Tunguska event flattened Siberian forests. Scale that up without lunar protection, and we'd face regular dinosaur killers. Dinosaur extinction? Just one bullet the moon intercepted. Satellites track it today. Near-Earth objects cluster near lunar paths, silently culled. NASA's models show moonless Earth suffering 10 to 20 times more large impacts, turning our blue marble into a battered rock. Every peaceful night, sky you gaze upon, every dinosaur fossil instead of mass graves, owes the moon's battered hide. It's not scarred decoration, it's armor etched with the strikes that spared us. Fifth salvation, cosmic bodyguard, intercepting doomsday rocks for 4 billion years. The moon bleeds so Earth can breathe. Sensing natural rhythms, every creature on Earth pulses to the moon's invisible beat. Sea turtles navigate 10,000 kilometers home by lunar light alone. Coral reefs synchronize mass spawning to full moon nights, releasing billions of eggs in tidal precision. Even humans feel it. Studies show full moons disrupt sleep. Deeper REM cycles vanish, melatonin drops 30%, hospital births peak during new moons. Our ancient brains still track that 29.5-day cycle wired into DNA over millions of years. Ancient civilizations decoded this rhythm. Mayans built pyramids aligned to lunar standstills. Druids timed solstice rituals by crescent phases. Islamic calendars follow hilal moons. Every culture's festivals, fasts, fertility rites, moon-scripted. Without lunar cycles, biology unravels, circadian clocks desync, no synchronized hunting packs, no mass migrations, no seasonal breeding. Ecosystems collapse into chaos. Intelligence requires rhythmic stability to evolve complex societies. Modern proof: aquaculture fails without artificial lunar lighting. Plants grown under constant light yield 20% less. Human shift workers suffer depression, heart disease from broken lunar sync. We're moon-wired machines. The moon doesn't orbit us from 384,000 kilometers away. Its gravity threads through veins, brains, oceans. Wolf howls, menstrual cycles, even stock market mood swings echo lunar phases. Biology isn't random, it's celestial choreography. Sixth miracle: universal metronome syncing life's symphony. From microbe division to human ambition, the moon conducts the rhythm that makes existence harmonious. One rock rules all heartbeats, preventing Earth from becoming Venus. 4.5 billion years ago, catastrophe forged our moon. A Mars-sized protoplanet smashed into early Earth, ejecting molten debris that coalesced into our lunar companion. But that violent birth did more than create a satellite. It saved our world from Venus's hellish fate. Venus spins next door, same size, same distance from the sun, yet it's a 460 degrees Celsius inferno with crushing acid clouds. Why? Runaway greenhouse effect. Early Venus lost water to solar winds. Volcanoes spewed unstoppable CO2, turning paradise into pressure cooker. Moonless Earth nearly followed. That giant impact stripped excessive volatiles, reset the atmosphere, allowed cooling oceans to form. The newborn moon's gravity then stabilized the system, preventing further collisions that could have triggered Venus-style volcanism. Without this lunar formation, Earth's mantle stays too hot, plate tectonics fail, carbon cycles break. Supervolcanoes blanket the globe in ash and gas for millennia. Oceans boil away. Atmosphere thickens to 90 times Earth's pressure, uninhabitable forever. Geological models confirm Moon's birth lowered Earth's rotation, moderated core heat, enabled magnetic fields strong enough to shield atmosphere from solar stripping. Venus drifted into hot zone unprotected. Earth stayed Goldilocks perfect. The moon didn't just form from destruction, it pulled our planet back from the brink. No runaway hell, fresh water cycles, breathable air. Life's chemistry ignites in stable cradle. Every raindrop, every lungful, traces to that cosmic reset. Seventh and greatest save, architect of habitability, transforming near-Venus doom into life's oasis. The moon's origin story isn't tragedy, it's Earth's ultimate redemption. 7 invisible interventions, 1 silent guardian. The moon didn't just watch Earth's story unfold, it engineered every chapter, from locking our tilt against cosmic chaos, to breaking our frantic spin into life's perfect rhythm. From tidal cradles birthing landwalkers, to intercepting doomsday rocks. From sinking every heartbeat, to preventing Venus-style hell, the moon sculpted our world from potential ruin into paradise. Without it, no stable seasons for farms, no 24-hour days for dreams, no evolutionary leaps, no shield from skies raining fire, no biological symphony, no breathable skies. We'd be a barren rock like Mars or scorched hell like Venus, silent, lifeless, forgotten. Next time moonlight touches your face, feel the weight of billions of years. That glow isn't romance or mystery, it's salvation. Earth's debt to the moon is everything we are, every city light, every child's laugh, every step toward stars. The moon wrote our existence, and in its light, we find our place in the cosmos, grateful, alive, protected. If someone said these moon facts without proof, they'd sound like wild conspiracies. But everyone is backed by science. The moon isn't just a rock, it's a cosmic anomaly. And the last fact, the most uncomfortable of all. 1. The moon is leaving us, right now. Picture the solar system in ultra-slow motion across billions of years. The moon, our constant night sky companion, slowly but surely drifting away from Earth, centimeter by relentless centimeter. Right now, as you're listening, it's receding at exactly 3.8 centimeters per year, the same pace your fingernails grow. In a single lifetime, this shift is imperceptible, but over geological timescales, it builds to hundreds of thousands of kilometers, fundamentally altering the Earth-Moon relationship that's dictated tides, days, and life for eons. This isn't some escape plot or hidden agenda. It's pure gravitational physics, a precise transfer of rotational energy. Earth spins much faster on its axis than the moon orbits us, causing ocean tides to bulge outward under lunar gravity. Because of our quicker rotation, those tidal bulges get dragged slightly ahead, creating a forward gravitational pull. that acts like a tow rope, gently boosting the moon into a higher, wider orbit with every cycle. But energy isn't free. The moon gains at Earth's expense, siphoning off our planet's spin and gradually lengthening our days. Ancient Earth days lasted around 22 hours with fiercer tides. Billions of years from now, they could stretch to 25 or 30 hours, weakening tides, disrupting ocean currents, and reshaping global climates in ways ecosystems might not survive. Apollo missions proved it irrefutably by placing laser reflectors on the lunar surface. Earth stations bounce beams off them today, measuring the retreat with millimeter accuracy. No fiction, no conspiracies, just gravity's inexorable math, where every tidal surge pays the toll for the moon's slow getaway. Our neighbor isn't frozen in place, it's moving away, stealing our time one subtle pull at a time, heading toward a future where the full moon shrinks and Earth ticks to a stranger rhythm. 2. We always see the same face, and it is not an accident. Picture staring at the moon night after night through every phase from sliver to full. Something profoundly strange reveals itself. We always see the exact same side, same craters and dark plains locked in eternal profile, as if deliberately refusing to show its other half while maintaining unbroken eye contact with Earth. Ancient civilizations whispered of cosmic secrecy, suspecting the moon hid something vital on its unseen hemisphere. But this permanence stems from tidal locking, a gravitational synchronization billions of years in the forging that binds the moon's spin perfectly to its orbit around our planet. The mechanics are precise. The moon rotates on its axis but completes exactly one spin every 27.3 days, the identical time it takes to circle Earth once. So as it travels its path, the same face stays perpetually oriented toward us, like a vigilant dancer never breaking gaze no matter the stage's turn. Earth's immense gravity braked the moon's original faster rotation through tidal friction, elongating its day until perfectly synced. Those same forces slowly pushing it away also froze this rigid stance eons ago, an unbreakable gravitational handcuff. True unease arrives with the far side, unveiled by spacecraft in 1959. No mirror image exists. The near side facing Earth features smoother terrain with vast, dark, basaltic maria, ancient lava floods filling impact basins, crafting the iconic man in the moon. The far side contrasts brutally, densely cratered, rugged expanse with fewer maria, thicker crust, and primitive scarring, suggesting divergent bombardment histories or cooling paths, while the near side got dramatically resurfaced. Two hemispheres, two geological sagas, one eternally displayed, the other veiled in shadow. This locked profile isn't random chance or artificial design, it's gravity's relentless choreography, weaving symmetry with profound concealment. The moon doesn't simply orbit, it stares back unchanging, shielding a wilder, ancient self that demands technology to witness. In that eternal gaze lingers cosmic truth. Our closest sky neighbor conceals deep divisions just beyond naked sight, proving what seems familiar often reveals only partial reality. 3. The moon has earthquakes, and they last for hours. Picture a desolate, airless world, utterly dead, no wind, no weather, just eternal silence under cosmic vacuum. Yet Apollo missions planted seismometers that captured something unnerving. Moonquakes shaking the lunar interior, some from micrometeorite hits peppering the surface, others from savage temperature swings between scorching days, plus 127 degrees Celsius, and frigid nights, minus 173 degrees Celsius that make the crust groan and crack. Earth's gravity adds insult, flexing the moon like a rubber ball with every orbit, building stress that snaps in seismic bursts. The real horror is duration. Earth's quakes strike hard, then fade in minutes. Energy soaked by water, faults, atmosphere. Moonquakes? They ring like a massive bell. Dry, brittle rock with no damping. Lets waves bounce for 10 minutes, even hours. Vibrations echoing through rigid depths. No plate tectonics drive them, just internal cooling contracting the core, still shrinking today. Tidal squeezes and thermal shocks, some hitting magnitude 4+ on Richter scale, felt hundreds of kilometers away. Apollo data proved it irrefutably. Instruments ringing long after impacts stopped. The moon isn't frozen corpse, we imagine. Beneath dust, forces churn, shuddering, resonating endlessly in slow cosmic agony. Not alive like Earth, but hauntingly restless, proving even dead worlds whisper secrets in prolonged tremors that outlast anything terrestrial. 4. There is water on the moon where it should not exist. Picture the moon as science textbooks sold it for decades. A bone-dry, dusty wasteland with no air, no rain, no hope of liquid anywhere under relentless solar glare. Yet NASA's instruments and recent missions uncovered something that rewrites that image. Vast reserves of water ice lurking in the deepest craters near the lunar poles, trapped in permanent shadow where sunlight never penetrates. These permanently shadowed regions stay brutally cold at minus 230 degrees Celsius or lower, cold enough to freeze comet-delivered water or volatiles released from lunar rocks billions of years ago, preserving them untouched since the solar system's chaotic youth. No atmosphere means no weather to erode or redistribute it, so ice endures in these lightless pits like cosmic time capsule. Discovery came from Chandrayaan-1's spectrometers detecting hydrogen signatures, confirmed by LCROSS impact plume analysis, showing pure water vapor, and recent Viper rover plans targeting these sites. What sounds impossible, water on an airless rock, is now proven resource jackpot. For explorers, it's revolutionary. Split H2O into breathable oxygen and rocket fuel, no hauling from Earth. Lunar bases become feasible pit stops to Mars, turning wasteland into strategic oasis. The moon isn't just gray powder anymore. Hidden ice vaults promise fuel, life support, humanity's next stepping stone. From sci-fi dream to mission-critical reality, proving even forbidden shadows hold Earth's future. 5. Lunar gravity is not uniform. Picture gravity as smooth and predictable, like Earth's gentle pull everywhere you stand. Yet on the moon, it's deceptively lumpy, hiding gravitational traps beneath its cratered skin. NASA's Lunar Prospector and Grail missions mapped invisible maskins, mass concentrations where dense rock lurks under ancient impact basins, yanking harder on orbiting spacecraft with sudden, unexpected tugs that wobble trajectories mid-flight. These anomalies stem from cataclysmic collisions eons ago. Massive asteroids punched through the crust, letting heavier mantle material rise or pool below, creating local gravity spikes up to 50 milligaules stronger than average lunar pull, about 1/6 Earth's. No uniform field means real peril. Apollo orbits had to dodge these hotspots meticulously, and modern landers like Artemis calculate paths with extreme precision to avoid orbital decay, fuel waste, or outright crash risks during descent. Sounds invented, patchy gravity on a simple moon. But Grail's twin probes confirmed dozens of mascons in major basins like Imbrium and Serenitatis, their gravity fingerprints distorting even low orbits hundreds of kilometers up, forcing constant mid-course corrections. The moon defies easy assumptions. Even its fundamental pull is scarred, treacherous. A reminder that beneath dusty calm lurks uneven danger from cosmic violence long past, not smooth satellite, gravity's scarred battlefield, where ancient wounds still pull unwary probes astray, turning routine flybys into high-stakes navigation check. 6. Lunar dust is toxic and extremely dangerous. Picture moon dust as harmless gray powder, fine and fluffy like beach sand. Yet Apollo astronauts called it fine, soft, almost like flour, that turned into deadly nightmare after just hours on the surface. Without wind, rain, or atmosphere for 4 billion years, constant micrometeorite bombardment hammers lunar regolith into jagged, glass-sharp shards, averaging 0.1 microns across, smaller than cells, electrostatically charged by solar wind to cling relentlessly like glitter to everything. Suits, visors, zippers, skin, tools, even floating inside landers. Inhaled, these razor particles shred lung tissue like microscopic confetti. Apollo 17's Harrison Schmitt got lunar hay fever with irritated throat, eyes, nasal passages. Long-term exposure risks permanent silicosis like scarring, chronic inflammation, even cancer from reactive iron nanoparticles. Mechanically devastating too. Valves jammed solid, cameras fogged opaque. Lander switches rendered useless by pervasive sticky buildup that no vacuum cleaner conquered. No erosion ever smooths those edges. It's pure weaponized grit forged in vacuum hell. The danger's brutally insidious. No cinematic explosion or visible threat, just relentless, slow sabotage grinding through suit fabric, inflaming lungs, corroding equipment seals over weeks or months. Future Artemis missions demand revolutionary countermeasures, airtight seals, electrostatic repellents, heated surfaces to shake it off, specialized fabrics woven to resist invasion. Moon's seemingly innocent dirt isn't neutral backdrop. It's a toxic adversary that actively fights back, proving even the finest powder evolves into humanity's deadliest foe in vacuum's unforgiving arena. 7. The moon is unusually large for its planet. Picture moons as tiny tags around gas giants like Jupiter's swarm. Yet Earth's moon defies every norm. Massive at 1/4 our diameter, 1/81st our mass. Biggest planet-to-moon ratio in the solar system bar, Pluto-Charon oddity. Most moons are captured asteroids or debris specks. Ours looms like a second world, visible in daytime, dominating tides with outsized pull that reshapes coastlines daily. Sounds engineered conspiracy, too perfectly scaled, but science pins it on giant impact hypothesis. 4.5 billion years ago, Mars-sized Theia slammed proto-Earth at 40,000 kilometers per hour, vaporizing both into debris disk that coalesced into moon, explaining its Earth-like rocks minus iron core, sunk to center, and identical oxygen isotopes. That perfect size raises chills. Too small, no strong tides for evolution. Too big, tidal locking too soon kills day-night cycles. Exact ratio stabilizes our 23.5-degree axial tilt for steady seasons. Without it, wild wobbles spawn ice ages or equatorial glaciers. Statistically freakish event birthed life-enabling guardian. Not random pebble, cosmic bullet that carved habitable exception from violent norm. 8. The moon stabilizes Earth, or life might not exist. Picture Earth stripped of its oversized moon, a spinning top wobbling violently over millennia, axial tilt careening from 0 degrees to 85 degrees extremes, unleashing chaotic climates. Ice caps marching to the equator one epoch, tropics locked in permafrost the next, seasons reduced to unrecognizable madness. Our precise 23.5-degree tilt delivers reliable seasons for agriculture and migration. The moon's gravitational pull acts as a massive gyroscope, damping those violent precessions that torment Mars. Tilt swings 0 to 60 degrees every million years, or destabilize most rocky exoplanets detected so far. Without this cosmic anchor, early life faces endless apocalypse. Photosynthesis cycles shattered, ocean currents halted, continental ecosystems repeatedly wiped in climate roulette. Evolution can't build complexity when environments flip every few 100,000 years. The moon locks our spin axis within a tight 1 to 2 degree variance over 100,000 year cycles, forging predictable weather bands where multicellular life explodes, from Cambrian burst to dinosaurs roaming stable continents, to humans forging cities under dependable skies. That giant impact 4.5 billion years ago forged the perfect counterweight. Too small, insufficient damping for wild tilts. Too massive, Earth captured into death spiral. Other rocky worlds drew cosmic short straws. No guardian moon, just relentless axial chaos. The moon isn't mere pretty ornament in our sky. It's silent engineer of habitability, cradling life's fragile spark steady against the universe's brutal entropy for 4 billion years. Without its watchful pull, no civilizations ever gaze back, wondering why. If these moon facts blew your mind, wait till you see what NASA's hiding about Mars's ancient oceans. Evidence of lost civilizations or just cosmic accident? The moon, humanity's greatest leap. But behind the glory lies a truth we rarely hear. 6 missions came within seconds of catastrophe, moments when one wrong move could have ended it all. Most people have no idea how close we came to losing everything, and it happened more than once. Apollo 11. Everyone remembers the first step. The image of Neil Armstrong setting foot on the moon is burned into history, but few people realize how dangerously close that moment came to never happening at all. As the lunar module Eagle began its final descent, Armstrong and Buzz Aldrin were focused, calm, but the systems around them were not. The onboard computer suddenly began flashing alarm codes, 1202, then 1201, both unknown. In Houston, no one was sure if they meant life or death for the crew. Controllers scrambled to decode the problem, and in seconds that felt like hours, they concluded it wasn't a failure, just an overload. The guidance computer was getting too much radar data, but it could keep running. The flight would continue. Then, at around 500 feet, Armstrong saw something that froze him for a moment. The landing site wasn't smooth like the photos. Instead, he saw a crater the size of a football field scattered with massive boulders. The autopilot was directing Eagle straight toward it. If they trusted the system, they'd crash. Armstrong instantly took manual control, a decision no checklist could predict. Now he was flying it like a helicopter, tilting gently, skimming over the lunar surface, searching for anything flat enough to land. But every second in the air burned precious fuel. 60 seconds, mission control warned. Then, 30 seconds. The tension was unbearable. In Houston, hands clenched. On board, sweat collected inside the astronauts' helmets. At under 10% fuel, Armstrong spotted a dust patch near the edge of a crater. He guided Eagle down, steady and silent as alarms blared. When the lander finally touched the surface, the engines cut out. For a brief moment, no one spoke. Then came Armstrong's calm voice. "Houston, Tranquility Base here. The Eagle has landed." Mission control erupted. Relief, disbelief, and triumph, all in the same breath. It's a perfect image now, but in reality, it was a knife's edge escape. 20 seconds more, and humanity's first moon landing would have ended in disaster. The difference between failure and victory wasn't technology or luck. It was one man's composure and instinct. Why it matters. The success of Apollo 11 wasn't guaranteed by machinery. It was earned through human courage under pressure. Proof that even in the cold void of space, survival often comes down to the human heartbeat behind the machine. Apollo 13. Apollo 13 was supposed to be the third moon landing, another smooth triumph for NASA. But what began as a routine mission would soon become one of the most dangerous survival stories in human history. 2 days after launch, on April 13, 1970, the crew, Jim Lovell, Fred Hayes, and Jack Swigert, were finishing a normal systems check when Mission Control requested a simple command: stir the oxygen tanks. Swigert flipped the switch. A few seconds later, the entire spacecraft shuddered violently. A muffled bang echoed through the cabin. Lights flickered, alarms screamed, and the oxygen gauge began dropping fast. Lovell's voice broke through the static. "Houston, we've had a problem." It wasn't just a small one. The explosion had destroyed one of the oxygen tanks and crippled the power systems. The command module, their only way home, was dying. Within minutes, they lost half their oxygen, most of their power, and their ability to continue the mission. The moon was no longer the destination. Now, survival was the only goal. NASA's plan was to use the lunar module, named Aquarius, as a lifeboat. It was meant for only 2 men for 2 days, but now had to keep 3 astronauts alive for nearly 4. Inside, temperatures dropped below freezing. Water was rationed to sips. They exhaled so much carbon dioxide that CO2 levels began rising fast enough to threaten suffocation. Improvisation became the law of survival. In Houston, engineers raced against time. The CO2 filters in the lunar module didn't fit the command module's system, literally square pegs in round holes. So, using nothing but items the astronauts had on board, plastic bags, duct tape, and cardboard, they devised a solution. Following instructions from the ground, the crew built a makeshift filter that saved their lives. One small invention stood between them and asphyxiation, but even if they survived, getting home was uncertain. With their trajectory altered, NASA made a bold decision. Instead of turning back, Apollo 13 would loop around the moon and use its gravity as a slingshot to return to Earth. The maneuver had to be perfect. Too shallow, and they'd miss Earth forever. Too steep, and they'd burn up on re-entry. The precision required was terrifying. Lovell, Hayes, and Swigert executed the burn manually, aiming earthward with almost no guidance data. As they passed the far side of the moon, completely out of communication, no one on Earth knew if they'd made it. When their signal finally returned, cheers erupted. They were coming home. After nearly 6 agonizing days in space, Apollo 13 re-entered Earth's atmosphere. 4 long minutes of radio silence followed. Then came the sound everyone had been praying for. Mission Control calling, "Odyssey, we copy you." The parachutes opened, and the capsule splashed safely into the Pacific Ocean. Apollo 13 never touched the moon, but it became a symbol of something even greater: ingenuity under pressure, teamwork in chaos, and human resilience against impossible odds. Apollo 13 proved that space exploration isn't just about science or success, it's about survival. When systems fail, it's human creativity that keeps hope alive. The mission that was once called a failure would go down in history as NASA's finest hour. Apollo 15. In July 1971, Apollo 15 launched as one of NASA's most ambitious missions yet, the first to carry a lunar rover and to focus on scientific exploration rather than just reaching the moon. Commanded by David Scott, with James Irwin and Alfred Worden, the mission went smoothly at first. The landing, the experiments, the breathtaking rover drives, everything seemed to go according to plan. But once the mission was complete, an unexpected technical problem nearly left 2 astronauts trapped forever on the lunar surface. The issue came down to one thing: the ascent engine. This crucial system was responsible for lifting the lunar module, Falcon, off the moon to rejoin the command module orbiting above. Without it, there'd be no takeoff, no rendezvous, no way home. Shortly before liftoff, engineers on Earth noticed something strange. Telemetry data suggested a possible electrical malfunction in the ignition circuit. The signal that should have confirmed ready status wasn't responding properly. The ascent engine had no backup and no physical way to fix it. The crew couldn't simply turn a key if it failed. If the electrical path didn't connect, the engine might never ignite. In the cramped cabin, David Scott and James Irwin waited for confirmation. They were calm, but they understood the gravity of their situation. Each switch they touched suddenly carried life or death weight. For engineers on Earth, time was running out. They traced the fault to a relay system, possibly damaged during descent. Rather than risk a full circuit failure, they decided to bypass portions of the ignition system and reroute power manually through the control panel. It was a high-stakes gamble. The modifications had to be executed flawlessly. If the rerouted power overloaded the circuit, there would be no second attempt. As the countdown began, Mission Control's room filled with uneasy silence. The command came through: "Falcon, you are go for ascent." Scott flipped the ignition command. For a heartbeat, nothing happened. Then, ignition. A low rumble built as the lunar module slowly lifted off the moon's surface, rising past the rover they had left behind. The crew stayed silent, focused entirely on the instruments, until orbital velocity confirmed success. Only then could they exhale. They successfully docked with the Endeavour command module, where astronaut Al Worden waited. Apollo 15 returned to Earth days later, a remarkable success on paper, though few knew how close it came to tragedy. Why it matters? On the moon, there's no backup plan. One failed circuit, one frozen valve, one flicker of an electrical fault, and rescue is impossible. Apollo 15 reminded the world that even decades of planning can come down to a single moment, when the only thing standing between life and death is a line of code and human resolve. Apollo 16. By 1972, NASA's confidence in lunar missions was at its peak. Apollo 16 was the 5th scheduled moon landing, commanded by John Young, with Charles Duke and Thomas Mattingly in orbit. The goal? Explore the moon's rugged highlands, a region unlike any they had visited before. But just hours before landing, everything changed. As the lunar module Orion prepared to separate from the command module Casper, Mission Control detected erratic data from a key guidance system, the Backup Attitude Control Unit. This system ensured spacecraft stability and safe re-entry. If it failed, the mission could end in disaster. The computers on Earth analyzed the readings and sent a chilling message: "Do not proceed with the landing." From the ground, it looked like a serious malfunction. A wrong decision here could trap the crew around the moon or lead to a fatal re-entry. Inside Orion, Young and Duke weren't convinced. The spacecraft felt stable, and their own checks didn't match the warning. They suspected a false reading, maybe just noise in the telemetry system. But in Houston, no one wanted to risk 3 lives based on a hunch. Hours passed as the crew and ground teams tested every system in silence filled with tension. Finally, after thorough diagnostics, Young reported, "Houston, everything checks. We're good to go." Mission Control hesitated, then gave them the go-ahead. The descent began. Seconds felt like minutes, but Orion handled flawlessly. The reading had been wrong. A false alarm nearly changed history. Apollo 16 completed its mission successfully, collecting valuable samples and conducting groundbreaking research. But that brush with cancellation left a mark. Apollo 16 revealed that in space, even bad data can be life-threatening. The crew's decision to trust both training and instinct proved that exploration isn't just about surviving the unknown. It's about daring to move forward, and when even the computers say, don't. Luna 15. While the world watched Apollo 11 prepare for humanity's first moon landing, another spacecraft was racing toward the same goal, though almost no one outside the Soviet Union knew it at the time. It was called Luna 15, a robotic probe launched by the USSR just 3 days before Apollo 11. Its mission was bold and symbolic: land on the moon, collect samples, and return them to Earth before the Americans could bring theirs back by hand. For the Soviets, beaten to the moon by astronauts, it was a chance to reclaim pride, to show that automation could succeed where human flight had only just begun. But the mission was rushed. Political pressure was enormous, and secrecy surrounded every step. Only a handful of Western scientists even knew the probe existed, and none knew exactly what it was doing. By July 20th, 1969, Luna 15 had reached lunar orbit, the very same day Armstrong and Aldrin were preparing to descend in the Apollo 11 lunar module. For a brief moment, 2 rival nations' missions shared the same tiny region of space, both operating around the moon at the same time. NASA and the Soviet Academy of Sciences even exchanged last-minute orbital data to make sure the 2 spacecraft wouldn't collide, a rare moment of cooperation at the height of the Cold War. But as Apollo 11's landing dominated the headlines, Luna 15 was quietly struggling. Its planned descent to the lunar surface was plagued with guidance errors. The probe's radar altimeter readings weren't lining up with the terrain, and Soviet engineers were forced to make rushed course corrections from Earth. With communication delays and incomplete lunar maps, each adjustment carried major risks. Just hours after Armstrong's first steps on the moon, the Soviet control team gave Luna 15 the command to begin descent. Observers in England's Jodrell Bank Observatory tracked the signal, until suddenly it stopped. At 3:50 p.m. Moscow time, Luna 15 slammed into the side of a mountain in the Mare Crisium region at nearly 500 kilometers per hour. The wreck scattered across the lunar surface, vanishing into silence. The mission was declared a failure. Official Soviet news barely mentioned it. To the public, it was as if Luna 15 never existed. But behind closed doors, it had been a massive disappointment, especially since it could have interfered with Apollo 11's triumph had it entered the wrong trajectory. Luna 15 is a forgotten story from the space race, a reminder that for every success written into history books, there are countless hidden failures that shaped the rivalry between nations. The crash showed just how dangerous the push for glory had become. Even as humans celebrated their first steps on another world, another machine, in that same moment, was falling from the sky. Surveyor 3. Before humans ever set foot on the moon, NASA had to prove one crucial thing: that landing safely was even possible. In 1967, the Surveyor 3 probe was launched to do just that. Its mission: touch down softly on the lunar surface, collect data, and test the technology that would one day carry Apollo astronaut. But when Surveyor 3 approached the moon, nothing went as planned. The descent was supposed to be smooth. The probe's engines had been designed to fire in timed bursts, gradually slowing it down before landing. But as it neared the surface, the radar altimeter misread its distance from the ground. The onboard computer thought it was closer than it actually was, and cut the engines too early. Instead of a gentle landing, Surveyor 3 fell the final few meters, hard. The spacecraft smashed into the surface, bounced, and then bounced again. For a few terrifying moments, engineers on Earth thought the mission was over. They assumed they'd lost another expensive probe in the endless list of failures that had plagued early lunar attempts. But to everyone's surprise, when the telemetry came back online, Surveyor 3 was still alive. Despite the impact, the probe stabilized on an uneven patch of ground in the ocean of storms and began transmitting images. Over the next several days, it sent back more than 6,000 photos from the moon, the first real close-up view of the lunar terrain. The data proved that the surface was firm enough to support a lander, not the deep, powdery dust scientists once feared could swallow entire spacecraft. The mission lasted 2 weeks, enduring extreme temperature shifts until the moon's long night froze its electronics. On paper, it was just another test, but its lucky bounce changed everything. 2 years later, Apollo 12 astronauts Pete Conrad and Alan Bean visited the site where it had landed. They touched down just a few hundred feet away, examined the old probe, and even brought pieces of it back to Earth. Why it matters. Surveyor 3 proved that even mishaps can lead to breakthroughs. What seemed like a failure became a foundation for all the Apollo landings that followed. On a world with no second chances, surviving a bounce turned out to be one of NASA's greatest strokes of luck. Every one of these missions came within seconds of disaster, and yet, they all survived. But not every story in space ends that way. In our next video, we'll uncover one that didn't, a moment when technology, courage, and luck all failed. You won't believe what happened out there.